I am the Director of Systems and Technology for the Division Chassis and Safety at Continental. Continental, is one of the industry-leading suppliers of advanced driver assistance systems technology as well as automated vehicle technologies. And because of that, we have a huge global reach, supplying technologies to almost every manufacturer on the planet. And of course, that makes us an interesting partner for NVIDIA. And the idea there is that we can take our expertise in systems and software engineering for ASIL-D systems, so safety critical systems, and combine that with NVIDIA's expertise in supercomputing technologies and deep learning solutions for automated vehicles. Combine that together to bring those automated solutions to the market in a faster way and on a global perspective. So we will combine engineering resources from both sides and develop a system which is targeted for level 3 autonomy for the 2021 timeframe as a starting point, and then scaling that, of course, beyond level 3 to levels 4 and 5 into the future. The ultimate goal, what we call Vision Zero, right? 0 accidents, 0 injuries, and 0 fatalities due to vehicle transportation. And the only way to ultimately get all the way there is with a fully autonomous ecosystem, taking driver error out of the loop. There will be a road to get there, and we're not going to get automated vehicles on the road and replace the entire fleet right away. So for us, we see two different paths to get there. One is the kind of evolutionary path of equipping more and more driver assistance technology into vehicles, and that'll be the vast majority of the volumes that are on the road, right? On the other hand side, we have to work also on this revolutionary approach towards self-driving for mobility as a service type fleets, right, where we have publicly shared usage of vehicles, fully automated vehicles. And ultimately that will get us to Vision Zero. And the most important aspect from a safety perspective is really understanding what is the residual risk when we deploy, right? So we're not going to be able to prevent every single accident from occurring, right? But it's very important to be able to understand what is the residual risk when you deploy these technologies, whether they be level 2 technologies or level 5 fully automated technologies. And that takes a lot of rigor when it comes down to the tool chains, understanding of the statistical nature of the situation, building simulation frameworks to be able to collect data but then extrapolate that data, to be able to really understand how your system will react in the real world, right? Because the real world is a lot different than a test track. The most important thing from a system failure perspective is that you really design the system to be fail operational by nature, right? In some cases that means redundant. In some cases that means to have, let's say, proper monitoring of the system, right? Where you really understand how the system is operating. Is it operating properly? Do I need to offload some of that processing to a secondary path? And making sure that the system is really designed for safety and designed for fail operation from the get-go, whether that be multimodal sensing, whether that be in the compute hardware or in the planning algorithms and driving functions, or whether that be in the actuators, the braking, the steering, the propulsion actuators, making sure that they're fail operational and redundant. Of course, we want to get the benefits of automated vehicles, but we could, by deploying too quickly and by deploying systems which aren't safe, you could have a totally negative effect, a contrary effect to the benefits that we're expecting. You control the deployment and you monitor the deployment, making sure that you do it in a stepwise, incremental way, and making sure that it's safe. We all come from a different perspective, right? So everybody's speaking from a different perspective. Everybody has their own agenda. But the interesting thing is all of the messages are very similar, and they're very, let's say, technology-centric. They're very supportive of deploying the technology and getting to the same end goal, which is a safer environment and a fully autonomous ecosystem down the road. And even though we take different approaches to get there, everybody has the same intent.